All right, let's talk logarithms. This is the sheet I gave you guys in class. I'm going to go over these in some nauseating detail. But first, let me just give you the answer straight away. That way, if all you're coming here to do is check your answers, here you go. Number 1 is E, echo. Number 2 is A, alpha. Number 3 is A, alpha. Number 4 is E, echo. Number 5 is A, alpha. And number 6 is A, alpha. All right, now let's see why. Now, if you've never studied logarithms before, much of what I'm going to say is going to seem like Greek to you, but that's fine. Just follow along as best you can, and then when you do finally get to logarithms in your studies, hopefully some of this will ring a bell, and you say, well, there we go, look at that. Okay, so I am assuming that you have a basic understanding of logs in order to do these problems. So, which of the following is a value that satisfies log base n of 144 equals 2? All right, well, first off, what does a log mean? If I have the log of some base b to some value a, and that equals some number c, log base b of a equals c, this is saying that b raised to the c power should equal a. B to the c, that's what a log means right there. So another way to write this would be b to the c equals b to the c equals a. There you go. So you can just think of it, you're moving counterclockwise. B to the c should equal a. B to the c should equal a. So here we have log base n of 144 equals 2. Well, this means that n to the 2 equals 144. So n squared equals 144. And since you've all memorized your squares and cubes, you know straight away the answer is 12, because 12 squared equals 144. Answer E. There you go. Number 2. Which of the following is a value that satisfies log base 2 of x equals 5? Well, we know how this works now, right? Log base 2 of x equals 5 means 2 to the 5 should equal x, so 2 to the 5th equals x. And I did encourage you guys to memorize your powers of 2, at least up to 2 to the 10th. Which if you did, you know straight away that 2 to the 5th is 32. So x is 32, which is answer A. There we go. Everyone laughed when Mr. Bird said to memorize your squares and your cubes and your powers of 2. But you're not laughing now, are you? Which of the following expressions is greatest? Log base 5 of 25, log base 25 of 25, log base 25 of 5, log base 625 of 25, or log base 125 of 5. Holy cow. Well, you might make a guess here that the smaller base will have the largest answer. And that won't always be true, certainly. But let's see. Let's sort them all out and see which one is indeed the greatest, okay? So right here, we know how this works. 5 to the what equals 25? Well, 2. 5 to the second power equals 25. This says 25 to the what equals 25? Well, 25 to the 1 equals 25, okay? Now 25 to the what equals 5? Well, the square root of, whoops, let's try that again. The square root of 25 equals 5. And I'm presuming you've learned all about fractional exponents. Another way to write the square root of 25 is 25 to the 1/2 power. Right? So the answer here is 1/2. Log base 625 to the 25. Similarly, the square root of 625 is 25. So that means 625 to the 1/2 equals 25. And lastly, log base 125 of 5 means what number do I raise 125 to equal 5? Well, 125 is the cube of 5. So the cube root of 125 equals 5. So that would be 1/3. So which one's the greatest? Well, answer A right there. There we go. Number 4. If log base m of n equals a and log base m of p equals b, then log base m of np cubed equals what? Heavens to Betsy, is there any way we could figure that out? Well, yes, there is, because logarithms are amazing. So let's start with this expression right here. Log base m np cubed equals what? Well, one of the properties of logarithms says that if I take the log of something that's raised to a power, let's say x squared, that I can take that power and pull it out and treat it like a coefficient. So log of x squared is identical to the 2 times the log of x. I can treat that exponent in the log as a coefficient. So I can do that here as well. Log base m of np cubed is the same as 3 log base m of np. There we go. So far, so good. Another property of log says that if I take the log of 2 things that are multiplied, the log of a product, okay, that I can write that instead as the sum of 2 separate logs. So I can write that as the log of x plus the log of y. So if I have 2 things that are multiplied together, I can split that up into 2 separate logs. The log of xy is equal to the log of x plus the log of y. So that means the log base m of np, I can rewrite that as 3 times the log base m of n plus the log base m of p. Well, there we go. Now it tells us right here in the problem that the log base m of n equals a, and the log base m of p equals b. So now I just have to distribute the 3. So this is 3a plus 3b, answer E. There we go. If you're hearing a crunching noise in the background, that is Willow trying to break into a bag of treats. I apologize for that. Willow. All right, what is the real value of x in the equation log base 3 of x plus log base 3 of 9x equals 4? Wonderful. Well, just as we split the logs apart here, in this case, I can combine those 2 logs. Now, all of these rules we just looked at are dependent upon these bases being the same. Since these are both log base 3, we can do this no problem. So I can rewrite these 2 as 1 log base 3 of x times 9x, which is the log base 3 of 9x squared, and we know that that equals 4. So now we know that what this means is that 3 to the 4th should equal 9x squared. So 3 to the 4 equals 9x squared. All right, well, 3 to the 4, that's just a number. That's 3 times 3 times 3 times 3, which is 27 times 3, which is 81, equals 9x squared. I divide by 9, so x squared equals 3. That means, oh, sorry, x squared equals 9. I misspoke there. So this should say x squared equals 9, which means x equals 3. There we go. Now I know what you're thinking. Wait a minute. Couldn't x also equal minus 3? Yes, it certainly could. Minus 3 squared is 9. But minus 3 is not one of our choices. And more importantly, x can't be minus 3 because you can't take the log of a negative number. If you're using the real number system, you can't take logs of negative numbers. If you're using complex numbers, then we can do that all day long. But with the real number system, we're confined to only taking the logs of positive numbers. So x can only be 3. Answer A. And finally, number 6. What is the real value of x in the equation log base 4 of 16 minus log base 6 of 36 equals log base 8 of x? Now it looks like our previous trick won't work. Okay. Incidentally, if I have two logs and they're subtracted, I can write them as the division. So let me just make note of that. If I have the log of x minus the log of y, I can write that as the log of x divided by y. But I can't do that here in any case because that's a 4 and that's a 6. Our bases are different. Okay? But we can figure these out easily enough. Log base 4 of 16 means 4 to the what equals 16? Well, that's 2, because 4 squared equals 16. Log base 6 of 36 means 6 to the what equals 36? Well, that's 2, because 6 to the second equals 36. And that equals log of 8 of x. 2 minus 2 is 0. So 0 equals log base 8 of x. Rewriting that, that means that 8 to the 0 equals x. Well, any number to the 0, whether it be 8 or 1,729, equals 1. So x equals 1. And there you go. Logarithms. Is there nothing they can't do?